So if we close down the Excel file and we close down this file here, you can see here that this other file that defines the boundary points is called a column file, and it has the extension CLI. If I open that up, if I say open, it'll probably ask me to nominate a program to open it, so I look at it in Notepad. And if we look at it in Notepad, what this basically does, it numbers each point on the open boundary going in an anti-clockwise direction, starting from the left hand side here. So this is point 1, point 2, point 3, and coming in an anti-clockwise direction. So you notice the very first point has the code 544, and then the rest of them have 222. So if I come back here, you'll see that it has a 544. That means it's an open C boundary. You can see it has the code here C. So the first node is node 1, then 2, 3, 4, 5 are all 222. That means they're closed boundaries. And if I go down all the way to the end, remembering it works in an anti-clockwise way, these points here are 544. That means they're open C points again. That corresponds, it numbers at number 1, then all the way around here, these are all closed, and then from here down to here are represented by these points here going in an anti-clockwise direction. The remaining points correspond to islands within the model domain. So that's the column file, and then the last file we have is the steering file. So if I look at this, this is used to specify all the model parameters that are needed to actually run the model. So if we open it up here, it's called a steering file. We don't use the Fortran file, that's commented out. We have the steering file as shannonk.str. The boundary conditions file is shannonk.cli. So that's the file I just discussed. The geometry file, which has the mesh, is shannonk.go. And the liquid boundaries file, that's the file that will read in the tide. That's shannonk.prn. When it runs the simulation, it also will output the results to shannonk2.slf in the same directory. It has some other parameters down here. The variables to output are the u velocity, the v velocity, and the height of the tide, and then you add every point. The time step is 10 seconds, and it's running for a duration of 2,591,900 seconds. It's approximately 31 days. The next one specified the frequency at which you output the values, and if I move down further, the law of bottom friction says we're going to use the Chasey value and the Chasey formulation for the bottom friction, and we're going to use a value of 50 for the Chasey value. So they are the main things that are needed to actually run a simulation. Type of advection, tidal flats is set to yes. That means that it can wet and dry, and the Shannon Estuary would have a lot of tidal flats. They are regions within the coastal area that wet and dry as the tide goes in and out. Okay, that's about it. That's what's there, the 4 files that are needed. To actually run it, I come over here to Telemac V7P0. I open up this window. I have to change to the directory where the files actually are. So the first thing I need to do is change to the Z drive. So Z : will change the drive. Then using the DOS command, change CD for change directory, shannonk. That will get me into that directory. If I do dir for directory, you see the 4 files are there. And then to run it, I type telemac 2d.py, and I put in the name of the steering file. So it's shannon.k.str. I press enter. It'll take a few seconds to set it up, but shortly it should come up with information that it's actually setting up the model to run correctly. It'll take quite a while. This mesh is quite detailed, so it could take somewhere like 10 hours to simulate 30 days. Now it's actually running, and this is the time you're always waiting to make sure that it's actually running correctly. It seems to be going well. I'll just let it run away there. And once you see this, the iteration here, 0 times 0, the liquid file contains this many lines, and it's using Streamline version 7 for the method of characteristics, and you you can see now that it's running correctly. Iteration 90, that represents 15 minutes, and it's actually outputting some results. So I'll let this run away overnight, and I'll use the results tomorrow. Okay, thank you for listening, and I'll follow on with some other videos to explain how the mesh is actually set up. Okay, thank you.